So now we're going to continue with our look at our planets by talking about magnetic fields. You probably know that the Earth has a magnetic field. This is how a compass works because the needle on a compass is actually a magnet, and it aligns itself with the magnetic field of the Earth to tell you what direction north is, because that's where the magnetic field lines go into the North Pole. So in any case, we're relatively interested in whether or not a planet has a magnetic field. It can affect the planet because the magnetic field can act like a buffer or a protection from the charged particles coming from the sun and other cosmic particles that are traveling through space. So we want to know which planets have magnetic fields and which ones don't, and why might they. Basically, in order for a planet to have a magnetic field, it needs some interior region of an electrically conducting fluid, which basically means for most of the planets it needs some molten metal. Remember that the core of the Earth was made up of nickel and iron, and I also mentioned that the outer core of the Earth was molten, so there you go. There's your electrically conducting fluid on the Earth. We need to have some motion of the charged particles in that layer, so you need to have some convection, which means that you need to have at least some sort of moderately fast rotation. So keeping these qualities in mind, we can sort of understand for the terrestrial planets why one might have a magnetic field while the other might not. So for the moon, remember the moon basically had a very thick lithosphere. It's geologically dead, so the molten core of it, which was actually pretty small, would not be, the metallic core would not be molten, so it does not have a magnetic field. Mars also has cooled off and also would lack that molten core that it would need to generate a magnetic field. Now Venus is a very hot planet, and we have no reason to believe that the core would not be molten. However, it has a very slow rotation, which is probably the reason that it doesn't have a magnetic field. Mercury has a magnetic field, even though it has a small size, and it does rotate pretty slowly, so perhaps it's caused by its very large core. If you remember, the size of its core was quite large in comparison to the rest of the planet. Another thing that surface feature that we see on planets is cratering. And the cratering more or less would have occurred during that period of bombardment shortly after the planets formed for millions of years. There was a lot of random material floating around in our solar system, and every time that hit a planet, it probably would cause a crater. In this series of pictures, you sort of see the stages through which the craters formed. Notice that the size of the impactor is actually quite small in comparison to the final size of the crater. That's because the objects come in with a very large speed, therefore they have a lot of energy, and this gives the impactor a lot of ability to create a large amount of damage. Both the moon and Mercury are heavily cratered, and you might want to try to think about why it might be true. Well, for one, these planets don't really have much of an atmosphere to protect them. If you think of a shooting star going through the Earth's atmosphere, that helps you think about how an atmosphere might protect a planet, because a lot of things that might hit the surface actually burn up in the atmosphere due to the friction. Another reason that the moon and Mercury are heavily cratered is due to the fact that their surface has probably not changed much since the period of bombardment because of the fact that they cooled off relatively quickly, and the geological activity that might have changed the surface and covered up those craters really came to a stop very quickly. Here's a crater on the moon that was given a name because remember Galileo did a lot of observations with his telescope and named a lot of objects on the moon. On the moon, we also have these different areas called the lunar maria and the lunar highlands, and those are areas that have very different appearances. The maria are very dark due to the fact of the material and the smoothness of those areas. We believe that the lunar maria would be younger features than the highlands, which are very cratered. And the maria were probably caused by very large impacts, and then that subsequently, early in the history of the moon, filled up with lava, which would eradicate a lot of the craters. There aren't a lot of craters within the maria, and they have that more smooth appearance. So here's a picture sort of illustrating this. Before they were the lunar maria, what it might have appeared before it was hit, and then you have a very large crater, and then it fills up with the hot material from the mantle, and then you have the mare, which remember was an Italian word for sea. When Galileo observed them, he thought that they might be actually oceans on the moon. Here's a picture of a crater on the moon, on Mars, that actually shows some interesting features. Notice that it doesn't have the sharp, distinct features that we saw on the moon, which means that there's probably been some sort of erosion taking place. Further evidence supporting the idea that Mars might have had water flowing on its surface in the past, and also if it had water, it probably was warmer, therefore there might have been more weather, and also could have had some wind erosion as well. Impact craters are rare on Venus, and we think that this is because of the fact that it's volcanically active. Most of the surface features that we see on Venus seem to be characteristic of some sort of volcanism, which would also go hand in hand with a hot interior, a very geologically active planet. Mars shows some signs of past volcanism. This is it has very large volcanoes on it. This is Olympus Mons, which is much, much bigger than Mount Everest, and other features within it show some signs of volcanism as well. However, these are all dead volcanoes. Mars no longer has any geological activity. Here's pictures of Venus, and as I said before, showing very distinct signs that show evidence of volcanic activity, and we're fairly certain that the volcanic activity may be going on today. Tectonics is something that we can also talk about, especially with respect to the Earth, which we really are basically talking about things, what's happening with the lithosphere on the Earth, and the different features and stresses that cause geological features. The idea behind tectonics on Earth, we call it plate tectonics, in that we think that the lithosphere of the Earth is made up of individual plates that are sort of, if you will, floating on the mantle. And as they move around, you can have things like continental drift take place, but you can also have the formation of mountains and trenches and earthquakes. The way that these tectonic plates move is through the convection that takes place in the mantle. Convection is when material, there's sort of a difference in temperature between the upper layer and the lower layer, which causes circulation cells to move, because as material gets heated down towards the center, and as it warms, it becomes less dense and it rises to the top where the heat can be lost, and then it becomes more dense and sinks down again. This circulation pattern is similar to what you might observe with a boiling pot of water. The bottom is much hotter than the surface, and as the water is in a roiling boil, this is really driven by convection. The convection we're talking about within the mantle of the Earth is, of course, much more slow, but it does cause some of the things that we see As it makes plates come together, it can cause mountains, or as the plates go separate from each other, it can cause trenches, like the trenches we see in the ocean, or valleys that we see on the surface of the Earth. One of the things we also see is sort of around the edges of the plates of the Earth, there's a lot of volcanic activity and also lots of earthquakes. And this ends up bringing up the term the Ring of Fire, which is the area around the Pacific, which is known to be very volcanically active, as well as being a place where a lot of earthquakes occur. Here's a picture showing how the continents have drifted over hundreds of millions of years, again due to the tectonic plates of the Earth moving due to that convection. Sometimes you have one plate move under the other, and this can cause different surface features like what is seen here on the surface of Mercury, which would have occurred much earlier in its history. Mars also shows some signs of tectonic activity. There's a very large trench that goes across the surface of Mars, which would actually stretch about the width of the United States. Again, though, right now there's not any geological activity going on in Mars at this time. And here's just a picture showing when the heavy cratering might have occurred, and then also when it would taper off, but also when other geological activity would have been happening for the different planets. Of course, here we say that there's still volcanic activity on Earth. We're not so sure about Venus, if it's still going on. We're not really sure when everything stopped on Mars, but Mercury and the Moon stopped relatively early after the formation due to their small size and the fact that they cooled off very quickly. Mars is interesting, as I've mentioned before, because there's lots of features on the surface that show signs of past water flow. In fact, this landing site for one of the rovers is believed to be a riverbed. You can see some sort of signs of water flow in this crater here. We see some signs of water flow in these features on the surface. And so that's sort of one of the big mysteries, is when did water flow on Mars and what caused the changes that we observe so that it became the way it is today. And that's where we're going to stop for planetary geology.